Right to do, yeah, all those, right to do it. So it's on and it just go right up. All right, let's start now. Somebody going on there. Why am I getting back myself? All right, let's start now. Somebody going on there. Why am I getting back myself? All right, let's start now. Somebody. Yeah. All right, good. Nice. So just a quick review of probability from Form 5. Right? Huh? What's still there? Wait, not there anymore. Go on. Well, that kind of blah. Right, probability of A is number in the event A over number in the sample space. Remember that all probability lies between what? All probability lies between 0 and 1. All right? We should remember that the probability of A and the probability of not A is how much? What's the probability of A and the probability of not A? If you add them up, 1. That'll be 1. Okay, but this is last week. Oh, probability of A and not A is 1, right? What about if I give you 2 events?
We should finish prove that folks.
Yeah, but we can put it all together as probability. Right? Suppose I gave you 2 events. Let's say I gave you 2 events, A and B. How do I find the probability of A union B? By sinus. Probability of A plus the probability of B minus the probability of. Right. Quick question. What does this mean and this mean in probability? Probability, yeah? Hello? No. No. Right, sorry. Right, yeah. In probability, what does the union represent? We use union to represent or and intersection to represent and. Right? I told you last week that or means what? Add or multiply? Add. And means multiply. Right? Just two little things to remember. What would happen if the question said that they are mutually exclusive? Anybody remember that? Mutually exclusive means that what? That they do not intersect, right? That they will be separate. Okay? Right? So mutually exclusive means that they do not intersect. Right? Boom, 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 boom. Right, next. What would happen if you have A given B? Whatever probability is this here. We call this conditional, right? So for conditional probability, A given B, how you find it? The probability of A and B all over the probability of B. Right? And what's the probability of B given A? Same thing, probability of A and B all over what? Probability of A. Right? What would happen if A and B are independent? What would happen? If one depends on the next, sorry, if one does not depend on the next, then the probability of A and B is what? Probability of A multiplied by the probability of B. Okay? So if things are independent, it means that these two, when you multiply them, you'll get this. Right? What would the answer here be? If they're independent, what would the answer here be? The probability of A given B. Huh? Somebody say that now. Probability of A. Right? Probability of A. All right? Because it's not dependent on B. B doesn't affect A. So it's just simply the probability of A. Gotcha? So why do we use tree diagrams to represent what type of probability? Right? Tree diagrams are used to represent conditional probability. So if this is the probability of A, this is the probability of what? B. Probability of? Not B, because this is A. Not A, very good. And if here's B, what's the probability here? What's this line?
Probability of B given.
Probability of B given that A happen. What's this line here?
Oh, yeah.
B not happening given A happen. Right? A happen directly. Okay? What about here? Probability of B happening given that A didn't happen. Probability of B didn't happen given that A didn't happen. Okay? So everything here shows you conditional probability, right? What would happen if you multiply here, Darian? If you multiply along a branch, what would you get? What's the probability of A by the probability of B given A? Very good. Probability of A and B. Right? What's this one here? Very good. Probability of A and not B. What's this one? One right. Not A and B. And last one. Probability of what? Not A and not B. Cristiano, if you add up all these probabilities, what you get? 1. Okay? So a completed Venn diagram means when you work everything out, everything here is 1, everything here is 1, everything here sums to 1, everything here sums to 1. Okay? So this is a full probability diagram. I mean a full review of probability. Let's target some questions which oh. Yeah. Let me see if I get a question here for you. Right, problem is my answer. Can I give you one homework? Victoria, ready one homework? Victoria, I cannot believe this. The same 2 minutes and filling Google form, please. Google form. on the group, and then you don't do it, please. That's the fix the one who got the one that I don't want. Yes. I want to go on and please. Just take a minute and let's fill out the Google form. And this spend 26 minutes. Mutually exclusive. All right, I have to call out the first one, right? That's okay? And with the mic, I'll take some charge. 4%. All right. How many numbers? 2019. It's 2019. Oh wait, everybody in a group, right? I got sent in a group. Huh? Yeah, I got sent in a group. I got sent in a group. I got sent in a group.
Last week.
You stuff. It's important. Yeah, everything was okay. Right, we're doing A and C. That's 2019, right? A and C. So that is
Yes.
number E, 5A and C. A and C.
So I didn't go.
Yeah, next to one.
I mean, I'm going to buy it. Yeah.
Have somebody to know it. Oh yeah, try that there quick. What time I want a small break?
Well, it's a small one.
5 minutes. Patient half. Let me say half cover.
Yeah.
Since we finished, we still, I'll send you the.
No, we just doing binomial theorem 6. That's the first thing in module 2. Yeah. What is adjustment is? Like somebody could like sign me up to leave it, don't I? Some people in the area, every area have one foot. But it happens San Fernando. So like if you lose something, you have to go back and sign up to yellow. Is it what? Okay. You don't think it has already. The argument too. Oh. It has more than one. Alright. Ready with the first one? Part A is still doing part A. Alright, go ahead. Yeah. Yeah, I see. If we lose it, we end up out there.
Yeah. But it's not needed to us. Well, no, it's a lot. They're good with sleeping.
Right, how many digits can make up 5 digits from the numbers 1, 2, 3, 4, 5, 6, 7, 8, 9? If each number contains exactly, right? So you have 5 digits you want to make, right? Each number contains exactly 1 even and no digit repeated. Right, so the even numbers we have are 2, 4, 6, and 8. Nice. So each number contains exactly one even digit and nothing repeated. Nice. So let's start. So 2, 4, 6, 8 could be there, right? So remember, 2 could be anywhere, right? So 2 could be here, 2, 3, 4, 5 spots where 2 could be. All right, so 2 has 5 options of where it could be. Multiply by how many other numbers remaining? 4. How many are we choosing from? Are we choosing from all? No, because if 2 is there, ignore 2, and we're choosing 1, 2, 3, 4, 5, 6, 7, 8. Does the order matter? Let's see. Let's say we choose 4. 3, 4, 5, 6. If I choose 4, 3, 5, 6, are these two different numbers? Are these two different numbers? Yes. Does the order matter? Does the order I choose them matter in? Yes. Everybody okay with that? Right? A little trick is whenever you have. All right, good. Yes. Only one even number. Excellent. So 1, 2, 3, 4, 5. Sorry, thank you. Right? You're not allowed to choose the other even numbers. Excellent. Right? Everybody okay with that? But this is important. P, because the order matters. Okay? Daria? You okay with P? What would this one be? Same thing? Same thing? 5 multiplied by 5p4. Same thing here. Right? So you multiply them and add them up. Right? Where the 5 come from, 8 could go in any other position. 8 could be here, 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 or here. So you have 8 options, sorry, 5 options where 8 could be. So I multiply by 5. Okay, the 8 can move.
Oh, no, yes.
Yeah, they can move. That's why it's 5p4. Oh yeah. How much is that? And then do the second part. That's not I'm in. No. Keep it to school. Yeah. This way. Yeah. Yeah. Right. And you have to do choosing. So you're choosing 19. So you're choosing 5 numbers. 1, 3, 5, 7, and 9. Right? Choosing from 5 numbers, you're choosing 4 numbers. So that's why we have 5 choose P. And the order you choose them in matters, so you put P. If the order don't matter, then you put C. How much you got here? 2400. Part 2 is what? Part 2, determine the probability that the number from A is less than 30,000. So the number has to be less than 30,000. So it's total. So you have to find the probability of less than 30,000. Total is 2400. You have to figure out now how much of these is less than this. Hurry up. The number that you get should not be bigger than this. Huh? So it has to be less than 30,000. Can you have a 2 in front? Number has to be? Yes, right. Correct. Yeah, less than 50,000. Go ahead. So you can't have 4 and 5 and 6 and can't have those numbers in front, right? Oh yeah, book out the probability. If it's done, you want to pass the What do you do? Yeah, figure out based on what it said, part one. Yeah. Put one. Figure out. What are you going? You know, two are a little bit hard to pay, but if you want, you can work with somebody, right? You can pick sure. She'll do our. Right, ready? Less than 30,000, right? Less than 30,000 means that I only have two options. I could have a 1 here, or I could have a 2. Right? Let's do the easier one first. Question said that I only allow one even number. Okay? So that means if I have one even number, 2 can move from there. 2 staying right there. Right? 2 staying right there. So that 2 has one spot. And then I have 1, 2, 3, 4 numbers. And how many odd numbers I have? 1, 2, 3, 4, 5. So I choose 4 from that. That's okay? You all follow why I put 1 here? Yeah. This 2 cannot move. Right? This 2 cannot move. Right. Because they allow one even number. And the number have to be less than 30,000. So 2 can't go anywhere. 2 staying right here in this scenario. What about here, Victoria? Can I choose any even number? Any even number, choose, right? Right? How many even numbers we have? 4 even numbers.
To be 4 multiplied.
So from the 4 even numbers, guess how we do that. From the 4 even numbers, we choosing 1. So I can put 0 P, it don't matter. We just choosing 1. Right? It don't matter. But remember that even number could move, and that even number could be here, 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 or here. So I'm multiplying by 4 as well. How many spaces? We have 4 spaces. So the even number could be here, 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 or here. Get that right? And lastly, how much remaining? 3 spaces remaining, right? Because remember, we pick a even number. 1 staying there. We have an even number somewhere. Right? I put E for even, right? So I have 3 more spaces now. How many are choosing from? I choosing from 1 gone, all the even gone. So I choosing from 3, 5, 7, 9. So I have 4 numbers. And I'm going to choose 3. All with me? Victoria, you sure? Wait over again. right? So I want you to remember how to do this, right? I laid out the scenarios that'll give you something less than 30,000. Less than 30,000 means it must have a 1 and a 2. Those numbers cannot move from there. If you pick up 2, you have 5 other numbers to choose from. If you pick up 1, you have to consider the even. So we have 4 even numbers. I'm going to choose one of them, and I can move them in 4 spots, here, 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 or here. And then I have 3 consonants remaining. Sorry, 3 odd numbers remaining, and a 2 and 4. How much is this? How much is this? Right? This is one of the topics that's challenging because there's so much different scenarios. You have to try to create a mirror. I mean, I'm map and work it out, right? You have to think it through and work it out. There's no one answer. You have to find a way to work it out. How much? Huh? Yeah, this is come. It was come for like a little piece in number 5. But how much you got here? How much? Somebody work out this now, please. 384. So the answer is 384 over 2400. Huh? 504. 504, right? Part C now. Part C. Part C, and let's see if we can do one more. We'll do 18. Oh yeah, Pete, do something, please. Part C. Oh yeah, part C. Part C is 2018. Next one is
Yeah, doing this, not doing it, that's what you should say.
Shut and see your name here. Waiting in block. Good. Part C now too. Very good. You have got part C. Oh, you have set it up, work it out. Remember, probably question you have Venn diagram or tree diagram, right? And let's see if you want to go. How many in an experiment, individuals are asked to select from two available colors, green and blue. The individual selected one color, two colors, or no color. So we might be able to put it in a Venn diagram or a tree diagram. Two colors available, blue or green, right? This might look good in a Venn diagram. Blue, green, no color out here, right? 70% of the individuals selected at least one color. 600, no color. Right? 70% at least one color. Right? That's 1, 2, and 0, right? Sorry, 1 and 2. Right, given that 40% selected green, given that the probability of green is 40%, probability of blue 50%, calculate the probability that an individual selected both colors. So you might remember your little Venn diagram work. So green is this whole thing here, right? So 40 is where? So if here's X, we don't know there. How much is here? Anybody remember? How much is here? If the whole thing is 40, here's, right? Here's 40 minus X. How much is here? How much is here? 50 minus X. If I were to add up here, here, and here, what would I get? Very good. If I add up here, here, and here, that's 70. Right? That's 1 and 2. One color, two colors. Are you okay with that? So therefore, if I add up 50 minus X, and 40 minus X, I'll get 70. So that means 70 is 90 minus X is 20%. So the probability is 0.2. Part 2. How we doing part 2, Marcus?
If you live that way, I think that way. I think I can reset the question. Maybe the next question, I'll get that. I think it's more like it's more science.
Oh yeah, part 2. Cristiano, read part 2, tell me what to do.
I see a lot of good at times. Yeah. Oh.
Right, I need some help. How I get the total? Darian, could you help me please? How I get the total number of individuals in the experiment? Right, so you take and you get how much? 30%. So 30% is equal to 600. What I need to do after the find 1 or the find 100 one time? Find 100 one time. So per 100 now is 600 over 30 multiplied by 100, right? So they end up with how much? 2,000 people. So ChatGPT, well done. Right? 2,000 people. Next one, 2018. Right, I'll send to the group. It's the last one we're gonna do, right? After this, we will take a small break and then start module 2. Right, remember, module 3 is this and matrices. That's one question. And then number 6 is differential equations. Right, so there's easy marks. Yeah. Oh yeah. Last one. That's what he.
So we don't actually have a deep question. Yeah.
So you oh, that's it, eight plus one, for the twelve, yeah, because you do this one, something.
Yeah.
I mean, those- They got some, Yeah, but that was my point, it's not.
Yes, I'm getting it.
Can be. Okay, get you. All right, let me go now. Earlier online. You all getting through? But I wanted a little 5 minute break.
Five.
I didn't do no questions, but I want more.
I do 3 questions. Yeah. Look at my book, my book full of it. Yeah. I get 50.
I'm not trying to do no questions.
Like Darian.
How much pictures are allowed? 3, and?
Yeah. Yeah.
Three. I don't give her 2 more questions. Let me see what you.
Yeah.
Huh? Alright, part A should be easy.
Yeah.
You want the probability of A and B. That's the probability of A plus the probability of B minus A union B. Right, that's 0.4 plus 0.45 minus 0.68. How much is this? 17? Yeah. Part 1, part 2. Determine whether it's independent. Well, to check if independent, multiply the probability of A by the probability of B. That's 0.4 by 0.45. How much is that? 0.1, which is not equal to A and B. Therefore, not independent. Part B, nice one here. Right? We need.
Part C. Do you see it now? I still don't.
Yes, sir.
All right.
Right, we have 4 persons to be chosen in a committee. We have 4 persons and we're choosing 8. From 8, I mean, including Mr. Smith and Mrs. Smith. Mr. Smith will not join the committee without his wife. True. Right? So this is Mr. here and this is Mr. 2 of them have to be there. But his wife will not join. His wife will join without him. And then we probably have a group with none of them in it. Right? So we have a group with 2 of them, one with Miss alone and one with nobody. All right? Does the order matter? Let's see. If you pick Ben and Jerry and Franklin, if you switch them around, Jerry, Ben, and Franklin, same group, so the order don't matter, right? Order does not matter. So it don't matter how we choose them, same group, right? So I have 2 people here, I have 6 remaining, so that's 6C2, right? What about here? I have 3 people, and I'm choosing from 6 again, because I can't choose Mr. Right? Mr. wouldn't be here. And lastly, I have 6 people and I'm choosing 4. Yeah.
6C2. You might get 2.
Because I need two people remaining. And I have to choose from the remaining 6. I take out 2 people. Look at them here. Do I have to rearrange them? Or it don't make a difference? It don't make a difference, right? So lay them out and then switch them around and see. How much is this? 6C2 plus 6C3. Add them up. How much you got? How much? 15 people. Darren said 15, eh? I will chat you. This is 15. All right, number part C. Part C, part C. Right? You want how many odd numbers? So you have 2 conditions, odd and greater than 500,000. You want to finish this one?
No, not yet. Yes,
All right.
yes. Not yet.
Well, Darren, of course you finish it. You're getting it from ChatGPT. I don't know. Oh yeah, we'll go to the last one. That's one you fix up.
Sí, los van a
Go to 5 and B2 plus 5 so you can get it. Do 5 and 7 B2.
multiply by I think that's serious. Yeah, multiply.
Right? If you want a number bigger than 500,000 or take out ending, right? Yeah, you can still include like
Yeah.
Right, so again, I just like to lay out what should happen, right? I'm giving you a minute again. Right, the next module we're doing is series and sequences, right? So that's like if we can that thing along that line, right? Right, as I said, this is the end of module 3. Your module 3 has probability matrices, that's number 5, and number 6 is differential equation, right? Right, so if you look here, this first one here. Let me start here, right? How are we doing this one? So the first option is that we stay with a 5. Right? You stay with a 5. And we have 1, 2, 3, 4 numbers, and then the last number could either be 3 or 7. 5 cannot be there. So we have 2 options in the end, and we have 1, 2, 3, 4 to choose from. And how many numbers we have? 2, 3, 4, 5, 6, 7. 3 and 7 going, and 5 going, so you have 3 numbers. Yeah.
And they'll need to go before. Because when
you choose
when
one of
you
the
choose one of
other
the
one,
other
the next one
ones,
is still gotta be in
the next one, yeah.
That's not.
Yes.
And check before calculating.
Yeah, of course I can't go to that's what I do wrong. Right, yes. Right. So when you choose 7, you have 4 numbers. And then when you choose 3, nice. But don't forget to put it 2 because you have 2 options here, right? With the 7 and with the 3.
Oh, Marcus.
This one, I like to.
Right? Here is what?
Yeah.
Here you're multiplying by how much? Here is how much? Oh wait, before you all do that, I want to show you something else here. Watch this here. If we chose 7, right? If we chose 7, we have 2, 3, 4, and 6. Those 4 numbers, that 4 spaces here, right? So do we need to select? No. We could just use 4 factorial. We could just rearrange them. So when you all find 4p4, it's the same as 4 factorial. That's okay? Here, same concept, 4 factorial by 3. Here, 4 factorial by 2. Okay? How much is that?
116.
How much?
116.
160. All right. That's the end of probability. And then take a 10-minute break, and then we start module 2. We'll start with something easy. Binomial electronics, right? Take a little break. 10 minutes, huh? And I started. We're not here, I started.
We're not start.
When it comes here, 10 minutes. expansion. Mhm. All right. So let's say you want to expand something like this. Right? Let's say you want to expand something like this. There's a nice little formula. You don't have to memorize it. It's in your formula sheet. There's a little formula that you have to learn, right? E to the n plus nc1. Well, remember this on the calculator. A to the n minus 1, b to the 1, plus nc2, a to the n minus 2, b2, plus nc3, all the way until you reach the last value. Right? Well, simple. Copy it down. I want to show you how to use it. Well, yeah, good to know it. Right? So I want to show you how to do an expansion like this, right? Right? As I said, you don't have to memorize the formula. It's in your formula, in your little formula sheet there. Right? Write the formula down. I want to show you how to use it, right? Right? This is the NCR thing, so I'll show you how to use it. Right? I'll show you where these values came from. We just learned some of them, right? Right. Are you ready? Right? So if you look at this here, right? You will see that 3. Oh gosh. You'll see that 3 is your A. This is your B, and this is your N. All right. Watch here. Yes. Follow watch here, please. Right. So if you use the formula, A is the first value, B is your second value with the sign. So A is 3, B is minus 2x, and is 4. Right? And we just going to plug it into that formula. How you know when to stop? When you end up with the same values here. All right? So watch it here. A to the power of n. So that's 3 to the power of 4 plus NC1, that's 4, 1. Right? 4, 1. By A is 3, to the n minus 1. Right? I just following the formula, right? B is how much? Please remember that B is the value and the sign, right? So B is minus 2x to the power of 1. What would the next term be, Shanna? What would the next one be? The same thing that we did in we did this in the demo, right? What would it be? 4c 2 by 3 to the power of 4 minus 2 by B is this minus 2x squared. Right? What's the next term? Joshua, what's the next term? What's the next term? You just follow the pattern. Four to the 3 by 4 minus 3 by 3, right? And last term is what? 4 no, B minus 2x to the 4. You'll recognize that all these powers increasing by 1, all these decreasing by 1. Right. Yes, we can get this from the table, right? But I want to show you something called Pascal triangle, right? It is used to help work out those values, right? Right? Watch this here. Just take a little glance here now. You don't have to learn this, huh? They just to show you where it comes from, right? Because you can put this in the calculator and you'll get the answer. So Pascal triangle works like this. You start at 1. And then the numbers around it is always 1. The number in the middle here is the sum of these two numbers. Right? And I'll explain what each one represents, right? Outside is 1. The number, sum this, you'll get a number here. Sum this, you'll get a number here. Right? Same thing again. 1, 1. 1 plus 3 is 4. 3 plus 3 is 6. 3 plus 1 is 4. Right? Let's do one more row. 1, 1. What go in here? 5. What go in here? 10. Right? Let's do one more. Oh, and 5 again. Let's do one more. 1, 6, 15, 20, 15, 6. That's called Pascal triangle. So if I ask for 4C4, right? Or 4C1 or whatever, again, the value is right here. This is the row 4 factorial. So here's what the row gives you. I don't have it here, but you don't really need to, right? But 4C0, that's the first one. 4C1, that's the second value. 4C2, that's the third value. 4C3, fourth, 4C4, last one. Okay? So you can get your values from there if you want. But of course, we have a table, right? So let's expand it out. 4C0 is 1. 3 to the power of 4 is how much again? 256. No? How much? 3 to the power of 4 is what? Oh, yes, yes. 3 to the 5. 81. 4C1 is 4. 3 to the power 3 is 27. And you write back here minus 27. 4C2, you'll see it there. That's 6. 3 to the power 2 is 9. Minus 2x squared is 4x squared. Then 4C3, that's 4. 3 to the 1 is 3. Minus 2x cubed is minus 8x cubed. And lastly, 4C4 is 1 by 16x to the 4th. Right? So you just plug in the values and you're done. So we end up with 81. What's this here? Well, it's 2 by 20, 4 by 27 by minus 2. Minus 2, 1, 6. What's the next one? Was 4 by 6 by 9. How much? Same thing? 216x squared. What's the next one? And the last is plus 16.
Yeah, 16.
Very good. Right? So that is your final expansion. Right? And again, to do this Kiran, you're using this basic formula here. Just write them was A, B, and N. Right? It goes as far as 5 and 6 something else. Right? I just want you to remember when you're labeling, this is your first term, second, third, fourth, fifth term, right? Okay, remember it like that, right? Right, and I'll show you a way to work it out when you just want a particular term. Right? This formula only works anyway when you reach it. Ready? I take it off. Try. I'm just taking off this here. Try this, please. Two x plus 3 to the power of 5. Give me a small number, right? That's where to get the hang of it. Do that place 2x plus 3 to the power of 5 then sharp. 2x plus 3 to the power of 5. Right? A and B it don't matter which one have it. Right? It doesn't very much.
I sit down. No, there's something different. Yes, sir. Yes. Say, it's around.
Yeah, it don't matter. It don't matter what is A and B, yeah? It can be 3 plus 2x. Right? But it doesn't matter. You can just leave this at A and leave this at B. You get the same thing in the end, right? Nade or nade. Who had one down? Yeah.
Let's look at everything.
No, it doesn't. Never in life. Never. Now, you're about 3 times I see that, boy. Yes, I said it about 3 times. It don't make a difference. Like your expansion, if you use this, will be x to the 5, 4, 3, 2, 1. If you do the next way, it just be reverse.
Because
The way the terms out, that's being reversed. You could ask a question, but you can't ask it after somebody asked it 3 times already. Yeah, what 2 to the 5 again? 2 to the 5. 2, 4, 3, or anybody got this?
Yeah.
Anybody get it?
Yes.
Right. Right. So the problem happens now when they say like to the power 20. You don't want to expand all that, right? So what you need to do, what you need to be able to do is they won't ask you to expand all to 20, but they will say, what's the 5th term? Or what's the 6th term? Or what's the x cubed term? Or what's the x 10 term? We need to find a way to work that out without having to do out all. And what we do is something called the general term. All right. So I want to show you how to use the general term to find the x cubed term. And that's right. So make a note of what the x cubed term is, and let's see how we can work that out. Right, Faith, listen now. Thanks. We're going to use general term to find this only. We don't want to have to do the whole expansion. Right? We have to do a little piece of the expansion. Right? Next small little head in there, using the general term. And when you finish, using the general term. Right? Write the general term for me, right? Online, you'll see another thing in blue there, right? Yeah. Should be able to see.
Let's go. I'm going to get a meeting for that. So, yeah, nice.
I think we did a general too. All right. You ready? So whenever we get large power of n, you don't expect us to expand all that, right? There must be a short way for us to find this. So in order for us to find, like, for example, the x cubed term, here's what you can do. Ready? Let's see how we're going to find the x cubed term, right? So I don't want to rub off all of that. Watch this here. So we know n is what? We know n in this question is 5. We don't know r as yet, right? We'll figure out r just now. A is what? A is 2x to the 5 minus something. And let's call it r, right? And here's 3. 3 to the power of r. Are you okay with that? Right? We know what is n, we know what is a, and we know what is p. Everybody okay with us? Right. Now, how do we find? We want to be able to find the x cubed term. Right? We want to be able to get the x cubed term. This one's simple because we know what has to happen here to get x cubed, but I just do not general case. Watch this here. So I'm going to expand this out a little bit. I'm going to expand this out. I'll get 2 by 5 minus r by x 5 minus r by 3r. Right? I expand this a little bit. 2 to this power, x to this power, 3 to this power. That's okay? What controls x cube here? What controls getting x cube? This here, right? That's okay? So since you want x cube has to be equal to x to the 5 minus r. So it means that 3 is 5 minus r is 2. Right? This one is simple. You all would have seen it here. But there are times when I'm going to give you fractions in here. So I'll give you 2x plus 3 over 5x squared and thing.
What?
Right? You have to simplify it like this. Bring your x's together and then compare what you need. Everybody okay with that? So we learned that r is 2. So now I can come here and say, well, 5c2 by 2x to the 5 minus 2 by 3 squared. When I work this out, I will get 720 x cubed. That's okay? This is the x cubed term. Right? So all we're doing, for those who are now listening, right? You want to get the x cubed term. So we plug in n, r, a, b, n, and r. We don't know r. We know everything else. Right? So what we're doing, take the right hand side, expand it a little bit, and I got this. Right? I got 2 to the 5 minus r, x to the 5 minus r, 2 to the r. I bring the numbers together, and I'm mainly interested in this because this controls if I get x cubed or x to the 4th or x to the 5. Right? So I want this value to be x cubed. So what I did, I took this and I make it equal to x cubed and I solve for r. So I know r now. So I could drop in r here. That's okay? I could drop in r there and hold it out. Yeah. And then it compare and you solve for r. All right? So you don't want to have to do the whole expansion. So now I know that the x cubed term is 720 x cubed. Everybody okay with that? So you're writing here, 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 and here, right? Oh yeah, I write it kind of bad, but I didn't want to rub this off. So right here, general term, right here, 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 then it. right?
Ah.
Like a little flow chart. So you're flowing. Okay. Copy them. Let's go into something like a trend. Let's see if we get some.
Like this. Oh.
Right? So the problem in questions like this is that we know A, B, and N, we don't know R. Right? So the objective is to find R. Copy it down, man. Let's try one from 2014 here. I erasing the whole thing, right? I erasing this. No, I erasing what I wrote before. But I was no where you going? I thought you morphed through the door or something.
Yeah.
Figure one here, right? And no, I'll get back and forth. Oh, shucks, I got the top. I have the NCR formula. Nobody is applied here yet. Don't let him send him nothing. Right? So I want to get part one. I want to get the X6 term. They want the X7 term too, right? But I just want the X6 term. Actually, let's do both, right? It's an easy one, right?
Everybody has the right now.
Oh, yeah. Oh yeah, find it feels good. X6 and X7 after, right? They actually reach to. Again, you start going. Yeah, huh? Yeah, but just one hour will do it. Right, it's mainly the x's you're interested in, right? So x to the 20 minus r is x to the 6. What you all got for r? 14? Nice. R is 14. So it's 20 C14. Remember, virtually all the examples wouldn't be this simple. Some will have an x term here and an x term here that you have to simplify, right? So it's the x terms that you're comparing to give you this. Okay? What's the answer now to that quick? 3 to the 14. 4, 7. No, I didn't give me the final thing. Really and truly, you're supposed to divide these two in part 3, but I didn't write them part 2. Right? So I guess you can leave it like this if you want. What's these two? Anybody work out these two?
Yeah.
What's these two?
Never mind.
Alright, anyway, it's 20, 14, 2 to the 6, 3 to the 14 by x to the power 6, right? All of this here, right? And then do x to the 7. What would r be here? This one is here. Because you already figured out r here. R was 14 here. What would r be in this one? 13, right? R is 13. 20 minus r is 7. So r is 13. No, don't worry. No, part 3 was to divide them and see what you get. Right? In fact, I'll make it do that one time. Since you want to simplify it. Part 3, do it one time now. Part 3, find x7 divided by sorry, x6 to x7. Find x6 to x7. Find this here. So it will simplify out for you. Don't worry to work this out, right? Don't worry to work out this exact values. Just divide them and tell me what you get. Divide the x6 term and the x7 term. Don't worry to give my answer for this. I don't want that. Just divide these two and tell me what you get. What you got? Right? Just divide the x term. Everybody okay with this? All okay with this? Divide the x term and x7, tell me what you got. Right? Just divide those two, right? Plug them in just like how you have them. 20C14, 2 to the 6, 3 to the 14, all over 20, 20C13, 2 to the 7, 3 to the 30. You all got this, right? So it's 7 too. Right? X6 over X7. And it should simplify to something nice.
Like, or 7, right?
Yeah. It should simplify to something nice. Right? Divided, come on, you got
3 and 4.
3 and 4x, right? Don't forget the x. Don't forget the x, right?
Yeah, 3x.
No. You can simplify it here. Right? So this is the sixth term, there is sorry, x6 term, x7 term, and you end up with 3/4. Put it in just like how you have it here, right? I'm gonna give you a fraction now. Block in, sorry. Move that area. Block it.
Yeah.
I'll block it, sorry. That's what. Try this here, please. Last one here. Find the coefficient of x to the 4th. Look at it here. You have two terms of x in it, a and b. Oh, yeah, Bamba. Try that last one there. Everything is simplified. Oh, yeah. Right, bring your x terms together, eh? Don't forget. Right, next week we're going to take a look at what has happened when n is a fraction or a negative value. This formula does not work anymore. This formula. Don't follow rules. And see how those share campaigns. Okay, there. Okay. We get why don't accept that? Right? Problem is R again, right? We don't know R. Right? Don't forget the minus sign, huh? It's minus 3x to the power of R. Right? So when you expand it a little bit, you're going to see a new problem arising here, right? 2 by 8 is 16 minus 2R. And here you have, right? Which terms here contribute to the x term,
Why don't you just one?
right? What will happen here?
That's
That's not. Which terms here contribute to the x term? These two, right? So how do you simplify it? Divide. When you divide in same base pair, you do powers. Minus, right? So you'll get x to the 16 minus 2r minus r by minus 3 to the r. That's okay? What does this value have to be? This value has to be what? 4. Right? So you have to figure out what value here will give you a 4. What value of r here will give you a 4. Yeah. You could change it. Right? 16 minus 3r is 4. So you have to find for r. R is how much? I got 4. Yeah? R is 4. Right? 4 minus 16 is minus 12. Right? It's 4. And you're done. And you're done. Plug in 4 now. 8C4 by plugging 4 here, I mean. Right? 8C4 by minus 3 to the 4. How much is that? Shall we follow went on? I just bring the x's together and simplify. And I know that this power here has to be to the power of 4. So I know that this has to simplify to 4. Right? So if you guys are going to give you, bring your x's together. And you know the power has to be whatever they ask you here. This one different, right? Because we had to look out after. You'll follow what I did here, right? Adelia? You'll follow what I did here? So whenever you have more than one x term, you put them together and then equate it to x to the 4th, right? Right? This is equal to x to the 4th. What would happen? Huh? What would happen if I said I want a term independent of x? What does that mean? So suppose I said find the term independent of x. Have no x value. So what I mean?
yeah, it is true.
It means that the power here is what? 0. Right? So this will be equal to 0. So if you see a question, find the term that's independent of x, that's what they mean. All right. So next week we'll continue with this, but we're going to look at what happens when this is a fraction and when it's negative. Right? We can't use Pascal triangle anymore. All right, online.